Hello, good morning, good afternoon. Okay, today I will be covering on the tutorial 6, okay, which is on descriptive statistics and hypothesis testing. Right, this tutorial is rather quite easy, right, quite straightforward if you follow the notes that has been given in the lecture slides as well, and then some of it you would have done before, right? Okay, anyway, let me go through the questions, and then I will just focus on certain parts which are more important, and some that you can figure out yourself or do self-learning. I will go a bit faster. Okay, so the first question, which is the data below, lists the number of times the students in a class were absent. So what you have to do is identify the minimum, maximum, median, quartile 1 and quartile 3. And the second question says that calculate the mean and standard deviation. So basically you just apply the equation that has been shared in your lecture slides, right? So first thing is first, which is when you're given a values like this, you have to first order in increasing order, right? That means arrange them in increasing order, right? For example, for the first one, you have to sort the data in ascending order, which is increasing, right? So all this data here, I have arranged it in an order of increasing from smallest 0 until the largest number here is 5. Okay, so as you can see. So the first question says minimum, maximum, median, quartile 1, quartile 3. So it's straightforward. Minimum is 0 after you arrange it, right? Maximum is 5. The 0 and 5 is mean and max. Okay, so the median is always, if it's an odd number, it will be the center value. So in this case, I think they are 23 values. So the center value is the 12th value. So you can directly say that is the median. But what you do if there's even number of values, then you take the center 2 and you find the average. But in this case, since it's an odd number, there are 23 values. So you take the center one, which is the 12th value. So you can see to the left of this number is 11 more values, and to the right is 11 values. So this is the center value. So that is median. Okay, what is quartile 1 and quartile 3? Okay, to keep it simple, let me see if I have any other example. Okay, never mind. I do not have an example here, but it's in another question. But anyway, the easiest way to find quartile 1 or quartile 3 is it is the median of the first half, the first bottom set of values, and the median of the top half of the values. Like in this case, this is median, right? So the set of values below the median is this, correct? Okay, let me highlight it as green. Okay, so what is the median of these sets of values? So in this case, they are how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the median is 5. The fifth value, which is 0. That is why Q1 here is 0. So that's the easiest way, right? Once you find a median, take the bottom values and find the median for that bottom set of values, and that median will be your Q1. Okay, now what is the Q3? It is the median value for the top values after the median value. So in this case, these 11 values, so the median will be 2. So that is why the Q3 is 2. So that is the easiest way to find the quartile 1 and quartile 3. But what happens if they are odd number here? But in this case 11, right? So you can straight away take the middle value. But if there is odd number, just like how you do for a normal median, right? The median to find for this is, of course, take the center 2 values and find the average, right? So in this case it's odd, so you can just take the center value. Okay, simple as that. Now, the second question, you just have to find the mean, right? Find the average of the values of the 23 values, sum up all these values, and then divide by 23. So you get a mean. Okay. So the answer should be 1.17, right? This should be your answer. 1.17 will be your mean. Okay. Median for standard deviation, this is the equation, right? As you know, x minus x bar, which means every value you have to minus with the mean, square them, right? Sum all, divide by n minus 1. N here is 23, so minus 1, because we are using sample here, right? And then square root it, you should get 1.53. Okay, I believe all of you would have got it. Okay, if you don't get it, then you can check in our group and we can always discuss. Okay. All right, for number 2, 10 patients at a doctor's surgery wait for the following length of time to see their doctor, right? So there are how many? 10 values here. All are in minutes, okay? Make sure they are all in the same unit. Okay, what is the mean median mode for this data? Simple. Okay, and the following question says that what measures of central tendency would you use here? So as you know, there's mean median mode, right? So which will be the best central tendency for this type of data? Okay, so first thing, arrange time in increasing order, right? And you see mean, when we calculated it, the mean is 15 minutes. Median is, because there's odd number, even number, so we have to find the average of the two center values. We get 10 minutes and the mode is 5 minutes. So you can see that the central tendency here varies, right? One is 15, another is 10, another is 5. So we suggest here that the best central tendency to be used is median. Okay, right, look at the justification. Okay, the median would be the preferred measure of central tendency to use here and not the mean, since there is outlier of 55 minutes. Can you see? This is the one value which is totally outside this data set. But anyway, in when you are doing any kind of experimentation or data analysis, sometimes what we do is this also considered as data might maybe just happen like one time, so what you can do sometimes, if it is it does not affect the outcome, you can actually decide to remove this value before you calculate the average. So if you decide to remove this value of 55 minutes, then you can still use central tendency of mean, right? Because that can give a good representation. Um, unless if there are so many outlier values and then you realize that it might impact, so maybe it's better to not remove every value, but instead of that, you just use median, right? Because median is not affected by the outlier values. Okay, why mode is not suitable? Okay, because it is just chance that there just chance that two people waited for the same period of time. That means if you can see, only for I think yes, only two people waited for 5 minutes, right? So the mode here is only for the 5 minutes, right? So because it's just chance that two people waited for the same period of time and all others waited for different time periods, so this is not really a suitable central tendency to be used. Okay, now moving on to question number 3. Based on the data below, calculate the quartiles and find the interquartile range. Okay, the following numbers represent the time in minutes that 12 employees took to get to work on a particular day. So you have to calculate quartile and also interquartile. Okay, so if this is the data, the first thing is you arrange them in ascending order. Okay, from 10 here, now arrange to 92. Okay, find the first quartile. As I mentioned, you can actually find the first quartile by okay, first let's see what is the median here actually. Okay, so the median here is actually, you have to, because it's a even number, right? Because there are 12, right? Even number. So the median will be this average of these two center values. Okay, 37 plus 38 divided by 2. So in this case, the first quartile will be here, right? The lower 6 values, right? So out of these 6 values, what is the median? So of course, these two, what is the average? You will get 25.5. So that is the first quartile. The top half will be, what is the median? 46 plus 52 divided by 2. The average which is 49. So now what is interquartile? It's basically Q3 minus Q1, which is 49 minus 25.5, which is 23.5. Okay, and then of course they also ask about the median, did they? Okay, if they didn't ask, the median here is of course the average of the center two values, which is 37 plus 38 divided by 2, 37.5. Okay, moving on to the next question. The table below gives the number of students in a given range who commenced a bachelor degree at University of Sydney in 1997. The age is given in whole years, and so the range 20 to 24 includes those students who had their 20th birthday and those who are 24 but not yet reached 25. that means it can go up to 24.9 something, right? So, but the moment it's 25, it's a different class. So thus the class interval 20 to 24 is a 5-year interval. Note also that under 20 and over 45, class are open-ended. Decide on a reasonable lower endpoint and upper endpoint respectively, and use them to draw a histogram. So this is very simple, right? So basically this is the table, right? Age under 20. And this is the class which is given to you, right? So you can plot this way, right? Which is frequency and then age in the year, all right? So basically here we put it as 15 because the interval below 20 is every bar here is 5 years, right? So the next will be 15 and the following will be 10. But we stopped at 15 is basically because at university we don't expect students less than 15 to be enrolled logically, all right? But unless they are super smart, maybe they would have enrolled by the age of less than 15. But looking at the general situation, so we just put as starting point here as 15, right? So above 45, you can go, it can be, I know some of you might have just put at 50, but it is an open-ended, so we don't know where it ends, this 100, the 45 and over, this 130. So assuming maybe it goes up to 60, right? But your answers might vary here, right? Even if you put 50, it's not wrong, okay? But yeah, we accept that answer as well, okay? All right. The following data set, now we're going for number 5. The daytime temperature in Melbourne for February 1998. Draw a box plot for the given data set. So if you see this is the data set, again, for box plot, you have to go and find out what are the things that you need, okay? Basically for box plot, you will need first quartile value, median, third quartile, and interquartile range, okay? There are some additional things that you can have for a box plot in order to see whether a value falls in outlier zone or not, right? So arrange the values in increasing order, and then as usual, you start finding the median, the first quartile and third quartile as we discussed in the previous questions. So I have found out here first quartile 23.5, median is 26, third quartile is 29.5, interquartile is 6. Now, I also found here the lower outlier threshold, which this is the equation, Q1 minus 1.5 times the interquartile range, which I got 14.5. And then for upper outlier threshold, I got 38.5, right? So any values that fall below this and any value that falls after 38.5 is considered as an outlier, and we try not to use that in our analysis. So if you can see, this is the box plot. You can actually put in the values here as well. It's just I did not put it here, but you can put it, the median equals to what, mean equals to what, you can put it here. But basically this is, let's see, the viscous here pointing at 21, okay, and here the upper right viscous pointing at 35. So that referring actually for you to your mean and your max, okay. So you can see the mean is 23, the max is 35. So the same, the mean is 21, okay, and the max is 35. So that is what you see, the mean pointed here and the max pointed here. So this is mean and this is max, okay. Here, okay. Sorry, I don't have okay, the box plot, as you can see here, minimum, first quartile, median, third quartile here, and the largest number, not an outlier, which is here. So any values that is beyond this and beyond this, okay, will be considered as an outlier. Okay. So the final question is, a principal at a certain school claims that the student in his school are above average. So this is a claim, right? The principal predicts or claims that their students are above average intelligence, but the mean population IQ is 100. Express the null hypothesis and alternative hypothesis in a symbolic form. Okay, this is symbolic form. Okay, I have explained in class that sometimes you can do it in symbolic like this, or you can also write in words, right? That means there is a relationship between this variable and the other variable. So that is in a word form. Okay, for example, in this case, the claim is the students' intelligence is above average. But mean is something that is accepted or commonly accepted currently. So what is commonly accepted currently is the population IQ is 100. So here the null hypothesis is mu, which is a mean, equals to 100. Okay, then you write your alternative hypothesis, which is the claim of the headmaster, which is something that you're going to test as well, which is the claim is that the students have above average IQ. So here the alternative hypothesis you can write as H1 or you can write as HA, right? Mu is more than 100. Okay, so simple as that. This is in a symbolic form. Okay, I think that is all for our tutorial 6, okay, which is quite straightforward. Please try this and check with your answers that you have done. If you have any question, you can always get back to your lecturer for your tutorial classes.